All right, guys, in this video, I'm going to go over a couple things relating to circles, continuing with 9.2, which we started off with degrees and radians. So just trying to make my screen a little bigger here for us. There we go. Okay, so just a review of two measures that we've seen before, circumference and area. And on this page, we're pretty much going to have a couple of formulas that are important for this section. So our circumference, if you remember, there was two ways to measure it. We could use 2 pi r, where r was our radius, or another formula for circumference was pi times the diameter. All right, and then area, hopefully we remember, of a circle is equal to pi times radius squared. So two important formulas, really three if you count circumference as two there, that we've seen before and that might come up in this chapter. But our new ones that we're going to have, and actually, if you guys remember, you may have seen these way back in geometry, are arc length and area of a sector. So arc length, then they kind of have it shown in this picture here in green, right? So that's going to be our arc length. It's a portion of the circumference of the circle. So I'm going to write that out here just to have it. So arc length is really a fraction of the circumference. So this formula might make a little more sense kind of in that context, but there's two different formulas depending on what units they give you the angle in. So if they give you the angle in degrees, we're going to use this first formula where our arc length is equal to, you take your angle, whatever it is, make sure it's in degrees, divide it by 360, and then multiply that by the circumference. Versus if they give you the angle in radians. And we're going to know if it's in radians because there won't be any unit. So if it's in degrees, they're going to give us that degree symbol. If it's in radians, they just state a number, usually like pi, right? So pi over 6 would be an example of a radian measure. So this would be our arc length is equal to our angle in radians times the radius. And they typically use theta. You could see in our picture over here, they call this central angle theta. So those are our two formulas for arc length. We have the same thing for area of a sector. We have two formulas, and a sector is essentially, it looks like a piece of pizza. So here, this is the sector. And if I color that in, that's the shape. It's like the shape of a slice of pizza, right? So it's a fraction of a circle. So I'm going to say fraction of area of the circle. And I'm going to put in parentheses, it looks like a slice of pizza. All right, and again, depending on the units the angle is, we have two different formulas for this. So if they give you an angle given in degrees, then our formula, and I'm going to write it out like area with a little sector here, is going to be the angle in degrees divided by 360. So really similar to what we had before for arc, but now we're multiplying it by the area times pi r squared. If the angle is given in radians, then this is our area of a sector formula. it's 1/2 theta, which is our angle, times r squared. So don't forget theta is angle in radians. All right, so I'm gonna kind of leave that there for a second. If you guys need to take a screenshot or copy anything down, feel free to pause. And I'm gonna do 2 examples using these formulas. So our first example is here. It says we have a softball field forms a sector. So that's this big shape, right? Like a slice of pizza with the dimensions shown. Find the length of the outfield fence is the first thing. So the outfield fence, we can see, runs along the outside of the circle. So what they're really asking us to find here is an arc length. So I'm going to use our arc length formula up top, and the angle that they give us right over here is in degrees. It's 90 degrees. So I'm going to rewrite our formula. Arc length is equal to, I'm going to just put theta in degrees divided by 360 times 2 pi r. And I'm going to fill in everything we have. So we have 90 for our angle. And then the radius, we could see in the picture, is 180 feet. All right, so I'm going to simplify as much as I can. And I would do all the numbers first. So 90 divided by 360, that actually simplifies to 1/4. 2 times 180 is 360 pi. And so here's one option, and usually how we leave our answers, 360 divided by 4 would be 90 pi feet. So that would be the exact answer with pi in it, and that's completely fine. If you put this in your calculator, if I did mine right, we'll get somewhere around 282.74 feet. So that would be our arc length. They also want the area, so that's sector area over here. And it starts off the same way, but then we're putting in pi r squared. So for this one, we'll have 90 over 360 times pi 180 squared. Again, I'm going to put this in my calculator. So this is 1/4. I'm just going to type 1/4 times 180 squared. And I work out to get 2025 pi. And our units would be feet squared since this is an area. If you just type everything in, including pi, our answer is going to be about 25,446.9 feet squared. All right, guys, so I'm going to just start you off on the next example, and then you're going to finish it up. Very similar to this example. It says, I baked a cake. Mrs. Shed baked a cake for her dad's birthday, but her husband cut a piece out and brought it to his work. At least he cut a perfect sector. Find the area of the cake that is left if the shaded region is missing. So we actually want to find this area that I just colored in blue. It's white in the picture. And they gave us the 95 is in the missing piece. So much more helpful for us would be this angle that's in the piece that we actually want. So to get that, I'm going to do 360. Let me use a better color here. Minus the 95 that was taken away. And that equals 265 degrees. So that's the angle that we should be using for our, we want the area of the cake left. So I'll just write out to start our sector. We're going to use 265 divided by 360 times pi radius squared. So you guys can simplify that to go through. All right, so you guys are going to try out the rest of these practice. I want to really quickly talk about one that has radian measure instead of degrees because we didn't do that yet. So I'm just going to put over here as a reminder, the arc length for radians is just theta, so just your angle times r. And the sector for radians is 1/2 theta r squared. So this one is radian since there's no degrees. So to find the arc, we would do theta, which is our angle, times the radius, and that's it. And I'm going to sneak in, it says meters. So I can just simplify. I know 3 goes into 12 4 times. So that's going to be the arc length. And we can leave it just like that. You don't need to put it in your calculators if you don't want to. And then the same thing for the sector. So that's going to be 1/2 our angle, 7 pi over 12 times the radius squared. So that's the start for that one. You guys can simplify, try the rest of these out, and post your work.